Hi class, this is Miss Traz. I am here trying to create a video for you that I'm hoping you can utilize to help you remember a few basic skills that you can use while trying to solve various algebraic equations. So in this particular equation that I have in front of me, two things jump out at me. First of all, I notice that we have lots of terms that contain fractions. I also notice that the denominators in all of these fractions are different. We have a 3, we have a 12, and we have a 4. And then the last thing I notice, which is also a little bit puzzling, or definitely going to be a little tricky, I notice that we have an x here and here. So we have a variable on two sides of the equation. So in this video, we're going to practice two skills. The first skill being learning how, or practicing how, to clear an equation of fractions so that we're only working with integer values, and then also to solve equations that contain variables on both sides of the equation. So the first thing that I want to do is a technique that I actually witnessed a student do today in class. I'm going to rewrite each term in my equation so that the denominators all match up. So I have to say, sit there and think to myself, what is the greatest common multiple? I have 3, 4, and 12. So if you're watching at your computer, maybe take a minute to pause the video and ask yourself, what is the greatest common multiple of 3, 4, and 12? Okay, hopefully you came up with the answer of 12. So I'm going to rewrite each of my fractions so that I have 12 in the denominator. So now bear with me, I'm new to this program, so I'm learning a little bit as I go. I'm going to rewrite my first term, 5 over 3. I'm going to rewrite that one as I need to multiply the top and the bottom number by 4. So I'm going to notate that a little bit. I'm going to just right here, so dot and then 4, to kind of show you exactly what I'm doing so that I can rewrite it with a 12 in the denominator. So I end up getting 20 over 12. And I'm going to use that same technique across the equation for all of my terms so that I can get 12 in the denominator. So my next term, get my pen back. My next term becomes, we have 2 over 3x. I'm going to multiply the top and the bottom by 4, and that should give me 8 over 12x equals, my next term, 25 over 12. I don't need to do anything to that fraction because I already have 12 in the denominator, so I'm simply going to rewrite it, 25 over 12. Now I can already see that I'm running out of space, so I'm going to shrink things down a little bit. Excuse me, I keep coughing. All right, now my next one, 5 over 4x. For that fraction, I need to multiply each term by 3 to get 12 in my denominator. So that will become 15 over 12, and I can't forget to include my x. And then lastly, and again I have to shrink down, I need to get a stylus for my iPad so that I can write more efficiently. So lastly, my last term will be 3 over 4. I'm going to convert that into 9 over 12. So all that we've done so far, we've gone from this equation up here to this equation down here. And I haven't really changed anything. I've simply rewritten it in a different way. So these are completely equivalent to each other. The only thing that's different is that every fraction in this second equation has a 12 in the denominator. Now, this is a technique that I've been talking about a lot in class that I'm hoping we can become more comfortable with. I'm going to use a different color to highlight what I'm doing. I'm going to put brackets around the entire equation, and I am going to multiply everything in this equation by the number 12. And you'll notice I wrote the number 12 on the right side. Normally I would tend to write it on the left, but in fact it really doesn't matter. Either way it works. Now, I'm just going to show you one example. What happens when I multiply 12 and 20 over 12, right? So I'm actually going to draw an arrow to show that that's what I'm doing. So I'm going to multiply, I'm just going to do the one example to show you how the denominator will disappear when I perform this operation. So I just need to move the screen down a little bit. When we take 20 over 12 and we multiply it by 12 over 1, the 12s cross cancel and we are left with 20. So it's no coincidence that I converted the denominator to 12 and then I multiplied my fraction by 12 over 1. That was a very deliberate choice on my part. And I did it so that I could simplify my term and rewrite it as 20. Let's just backtrack. Originally, we started with this right here, 5 over 3. And we've managed to rewrite it as 20. And I think that is a simpler way to think of the term. I'm going to do that same process for every term in this equation. I'm going to take 12 over 1, and think of it like that actually. Think of it as 12 over 1. I'm multiplying each term in the equation by 12 over 1. So when I go ahead and rewrite my equation, now I'm going to have 20 plus 8x equals 25 plus 15x plus, I need to just make sure it's 9 over 12 plus 9 over 12. Oh, rather, plus 9, because I multiplied 9 over 12 by 12 to get 9. Now, I really like my new equation because it's very simple and there are no fractions. Now, from here, I have a few options. I'm thinking that it would make sense to combine any like terms that I can. So I notice over here I have a 25 and a 9. So I'm going to rewrite that side of the equation as 34 plus 15x. And then on my left side, I'm simply going to rewrite 20 plus 8x because there's nothing that I can collect or combine. Now, we're in that situation that I talked about before. We have a variable on the left side right here, and we also have a variable on the right side over there. So I am going to choose, I have a few options. I could either subtract 8x from both sides, which I think is what I'm going to do. Or if I preferred, I could have subtracted 15x from both sides to bring this term over here. But I picked 8x first, so I'm going to stick with that. I'm going to draw a little kind of equation bar to represent that I'm doing an operation. And my new equation will look as so. So the 8x's cancel out, and now I have a 20 equals 34 plus now 15x minus 8x. I'm looking at, oops, I did not want to do that. Okay, that's kind of scary when I accidentally shift everything. Okay, so we have 15x minus 8x right here. This is what I'm looking at. That can be rewritten as 7x. Now, this equation is starting to look simpler and simpler, which I like. The next step, I think, in this equation would be to get this 34 away from my variable, because getting back to the basics, the goal is always to isolate the variable. So I'm going to subtract 34 from both sides of the equation, minus 34 from both sides. Here, the 34's cancel out. And then on the left side, we have 20 minus 34, which equals, I'm going to write parentheses, negative 14. Okay? So I'm going to rewrite my entire equation just to make sure everyone is entirely clear about my thinking. So I have negative 14 equals 7x. Now, there's one last and final step to complete in order to find our solution. Again, in keeping with the idea that I want to isolate my variable, I'm going to look to the right side of the equation and ask myself, what operation do I see here? And I see 7 times x. So I'm going to perform the opposite operation and do division on both sides of the equation. And in this particular case, I'm going to divide both sides by 7 because I want to get rid of the 7 that is next to my variable. So when I do that, the 7's cancel out, and now I have on the left negative 14 divided by 7 equals x. And negative 14 divided by 7 equals negative 2. I probably shouldn't have written it like that. Actually, I'm going to erase that. So instead, I will draw arrows. So this side becomes negative 2 equals x. And I'm going to get a nice bright green, and that is my answer. Okay. Now, if this video weren't already 12 minutes long and counting, I would take my answer, which is that x equals negative 2, and you'll notice that's written kind of backwards from what you're used to, and that's totally fine. I would take my answer, x equals negative 2, and I would go back up to my original equation all the way at the beginning, and I would plug it in to check it out. And perhaps I'll do that in a future video, just to show you that it is in fact correct. So, if you have any questions, I highly recommend that you go back and you rewatch this video and use your math journal to share with me specific thoughts, questions, or concerns that you may have. Thanks, and I hope you enjoyed watching my first video.